Continuing with our study of implicit differentiation, we're going to start with example 3. Find the coordinates of the where the graph has a horizontal and vertical tangent lines. And as soon as we see tangent, we know we're taking a derivative. Alright, so we're taking the derivative of both sides with respect to x. So on this side we get 2x. Then we could write dx, but that's just 1. So then we have 2y, dy dx, and the derivative of any constant is 0. So we're trying to solve for dy dx. So we should move anything else to the other side. So 2y dy dx equals negative 2x. Negative 2x. Okay, so then dy dx, if I divide both sides by 2y, I would end up with negative x over y. So the first part of this problem is asking where it has horizontal tangent lines. So horizontal tangent lines, we know that the slope should be 0, and instead of using slope, our dy dx. Where that equals, the top is 0, and the denominator is not 0. Okay, so where is the numerator 0? That's when x is 0. So if I plug in 0 for x and solve this, we're trying to figure out where y squared is 25. So we take the square root plus or minus the square root of both sides. We get y equals 5 and negative 5. So we have two places where there are horizontal tangent lines at 0, 5 and 0, negative 5. Okay, when we talk about vertical tangent lines, our slope, or our dy dx, is undefined. So that means we can't have 0 in the numerator, and we want 0 in the denominator. So this time we're setting y equal to 0. So we're going to have x squared plus 0 squared equals 25. Solving this, we get x equals plus or minus 5. So we're going to have the 2 points, 5, 0, and negative 5, 0, where our function has vertical tangent lines. The last question is, at what point is the slope 3/4? Well, then we just need to set our slope, or our derivative, equal to 3/4. And solving this, don't just assume that x is 3 and y is 4. Alright, actually set this up and solve it. So I'm going to solve for x. You can solve for either x or y. It doesn't really matter. Okay, so we get negative x equals 3/4 y. So x equals negative 3/4 y. When I'm trying to figure out a point, I need an x and a y coordinate. So I'm going to take this in and solve for the points. So instead of writing x, I'm going to write negative 3/4 y, quantity squared, plus y squared equals 25. Okay, solving that, again, 9/16 y squared plus y squared equals 25. Using a common denominator here, 16 over 16, you get 25y squared. 25 over 16y squared equals 25. So we know that y squared equals 16, and plus or minus the square root of that, y equals plus or minus 4. Okay, so plugging this back in, if y equals positive or negative 4, we get the coordinates negative 3/4 and 3, negative 4. Those are the 2 points where the slope is 3/4. Now we had an easy function. You should recognize that as a circle centered at the origin with a radius of 5. That's why these points are so easy. But if we can do this with an easy problem and our calculus is sound, then we can apply it to a tougher problem, such as the next one. Okay, example 4. we're looking for the same kinds of things, horizontal and tangent or vertical tangent lines. So we're talking derivative, so we just have to practice our implicit differentiation. So we get 4x plus, here we're going to have to use the product rule, okay, the first times the derivative of the second, which is dy dx, plus the second times the derivative of the first. And remember, the derivative of x is just dx over dx, or 1, right, plus, using the power rule here, 8y dy dx. And the derivative of any constant is simply 0. Alright, we're trying to solve for the derivative. So we're going to have to get anything with a dy dx on one side, anything else over to the other side. So I get x dy dx plus 8y dy dx. And anything else I'm just going to move to the other side. Minus 4x minus y. Factor out a dy dx. We get x plus 8y. And then our last step, after I rewrite this, okay, our last step is to divide both sides by x plus 8y. So dy dx, dy dx equals negative 4x minus y all over x plus 8y. Okay, so now we're looking, where do we have horizontal and vertical tangent lines? This is very similar to what we did before. When we're talking horizontal, we want dy dx to be 0. Okay, so that's our numerator. So negative 4x minus y equals 0. And I could choose to either solve for x or y. In this case, it looks like y would be easier to solve for. So I get y is negative 4x. To figure out the points where y equals negative 4x, I just have to substitute that back into the original. So we have 2x squared plus x times, and instead of writing y, I'm going to write negative 4x plus 4 times negative 4x quantity squared equals 3. Simplifying this, we get 2x squared minus 4x squared, and I can't tell my signs there. That should be a plus 64x squared equals 3. Alright, adding those together, we get 62x squared equals 3, and solving that, we get x equals plus or minus square root of 3 over 62. Now, if you really want, you could try to simplify this, you could rationalize it, but you don't have to. Just leave it there. Alright, now if we were looking for the points, we would just plug in 3 over 60, square root of 3 over 62, that's our x, and we know we can just multiply that by negative 4 to get our y value. Okay, and then we also had negative square root of 3 over 64, or 62, sorry, and now we can just multiply that by negative 4, so we get positive 4 over, or times the square root of 3 over 62. So those are our two coordinates for the horizontal tangent line. Vertical, we know that our derivative has to be undefined. So we're doing a similar kind of thing, except for we're starting with x plus 8y We want the denominator in this case to be equal to 0. Alright, solving this, we get x equals negative 8y. Okay, plug that into our original function, just like we did before, and you guys go ahead and do that. And at the end, I believe you should get negative 8 times the square root of 3 over 124, comma, square root of 3 over 124, whoa, square root of 3 over 124, and the other point would be positive 8 times the square root of 3 over 124, and negative square root of 3 over 124. Okay, so you should be able to finish that one out, just simply algebra. And on to our last problem of the day, to determine the equation of the tangent line of that at that point. So here you just have to take the derivative of both sides, and I'm not going to show that just for the sake of time. I'll show this step up here because it takes me a little bit longer to write this. Alright, I'm going to start out by taking the derivative of both sides. So we have to use the chain rule here. We have 6 times x squared plus y squared. Subtract 1 from the power, so that'd just be 1, times the derivative of the inside, which would be 2x plus 2y dy dx. Okay, that's it for that side, equals, and we have 100, the first, times the derivative of the second. We have to use the product rule here. 100x dy dx plus, right, the second function times the derivative of the first, which would just be 100 times y. 100 times y. Alright, so we could, at this point, expand all this out and solve for dy dx, but we actually already know the point that we want to plug in. So here, you could just plug in x equals 3, y equals 1. So at that point, 3, 1. Plug in those x and y values and simplify here. And I believe that we end up with dy dx equals 13/9. Okay, and you guys are getting really good at this, so I want you to show that work here. And then we just need to find the equation of that line. Well, we have a point, we have a slope, so y equals 1 plus 13/9 x minus